A mathematician is a person with an extensive knowledge of mathematics, who uses this knowledge in their work, typically to solve mathematical problems. Mathematics is concerned with numbers, data collection, quantity, structure, space, models, and change. Mathematicians involved with solving problems outside of pure mathematics are called applied mathematicians. Applied mathematicians are mathematical scientists who, with their specialized knowledge and professional methodology, approach many of the imposing problems presented in related scientific fields. With professional focus on a wide variety of problems, theoretical systems, and localized constructs, applied mathematicians work regularly in the study and formulation of mathematical models. Mathematicians and applied mathematicians are considered to be two of the STEM, science, technology, engineering, and mathematics, careers. The discipline of applied mathematics concerns itself with mathematical methods that are typically used in science, engineering, business, and industry. Thus, applied mathematics is a mathematical science with specialized knowledge. The term applied mathematics also describes the professional specialty in which mathematicians work on problems, often concrete, but sometimes abstract. As professionals focused on problem solving, applied mathematicians look into the formulation, study, and use of mathematical models in science, engineering, business, and other areas of mathematical practice. Mathematicians usually cover a breadth of topics within mathematics in their undergraduate education, and then proceed to specialize in topics of their own choice at the graduate level. In some universities, a qualifying exam serves to test both the breadth and depth of a student's understanding of mathematics. The students who pass are permitted to work on a doctoral dissertation. Motivation. This section does not cite any references or sources. Please help improve this section by adding citations to reliable sources. Unsourced material may be challenged and removed. March 2013. Mathematicians do research in fields such as logic, set theory, category theory, abstract algebra, number theory, analysis, geometry, topology, dynamical systems, combinatorics, game theory, information theory, numerical analysis, optimization, computation, probability, and statistics. These fields comprise both pure mathematics and applied mathematics, and establish links between the two. Some of the fields they work in such as the theory of dynamical systems, or game theory, are classified as applied mathematics due to the relationships they possess with physics, economics, and the other sciences. Whether probability theory and statistics are of theoretical nature, applied nature, or both, is quite controversial among mathematicians. Other branches of mathematics, however, such as logic, number theory, category theory, or set theory are accepted as part of pure mathematics, though they find application in other sciences, predominantly computer science and physics. Likewise, analysis, geometry, and topology, although considered pure mathematics, find applications in theoretical physics, string theory, for instance. Though it is true that mathematics finds diverse applications in many areas of research, a mathematician does not determine the value of an idea by the diversity of its applications. Mathematics is interesting in its own right, and a substantial minority of mathematicians investigate the diversity of structures studied in mathematics itself. However, among academic mathematics, the majority of mathematical papers published in the United States are written by academics outside of mathematics departments. Furthermore, a mathematician is not someone who merely manipulates formulas, numbers, or equations. The diversity of mathematics allows for research concerning how concepts in one area of mathematics can be used in other areas too. For instance, if one crafts a set of solutions of an equation in some higher dimensional space, he may ask about the geometric properties of the graph. Thus one can understand equations by a pure understanding of abstract topology or geometry. This idea is of importance in algebraic geometry. Similarly, a mathematician does not restrict his study of numbers to the integers, rather he considers more abstract structures such as rings, and in particular number rings, in the context of algebraic number theory. This exemplifies the abstract nature of mathematics, and how it is not restricted to questions one may ask in daily life. In a different direction, mathematicians ask questions about space and transformations that are not restricted to geometric figures such as squares and circles. For instance, an active area of research in differential topology concerns itself with the ways one can smooth higher dimensional figures. In fact, whether one can smooth certain higher dimensional spheres was, until recently, an open problem known as the smooth Poincare conjecture. Another aspect of mathematics, set-theoretic topology and point-set topology, concerns objects of a different nature from objects in our universe, or in a higher dimensional analog of our universe. These objects behave in a rather strange manner under deformations, and the properties they possess are completely different from those of objects in our universe. For instance, the distance between 2 points on such an object may depend on the order in which you consider the pair of points. This is quite different from ordinary life, in which it is accepted that the straight line distance from person A to person B is the same as that between person B and person A. Another aspect of mathematics, often referred to as foundational mathematics, consists of the fields of logic and set theory. These explore various ideas regarding the ways one can prove certain claims. This theory is far more complex than it seems, in that the truth of a claim depends on the context in which the claim is made, unlike basic ideas in daily life, where truth is absolute. In fact, although some claims may be true, it is impossible to prove or disprove them in rather natural contexts. Category theory, another field within foundational mathematics, is rooted on the abstract axiomatization of the definition of a class of mathematical structures referred to as a category. A category intuitively consists of a collection of objects and defined relationships between them. While these objects may be anything, such as tables or chairs, mathematicians are usually interested in particular, more abstract classes of such objects. In any case, it is the relationships between these objects, and not the actual objects, that are predominantly studied.